We're going to be using this syringe to measure volume changes. There's gas in there right now. Of course, we don't have anything stopping it off, but this is the gas. This is the air we're breathing, so it's a mixture. We've got nitrogen, oxygen, carbon dioxide, argon, trace other gases in this mixture right here. So this is a gas, even though we can't see it. Of course, you can feel it when you squeeze it out. So you know there's a gas in there. We're going to see what happens to the pressure if we seal this off and we start changing the volume. So we're going to seal it right in here. This is a closed system. See, there's like no exit. So I'm going to close this off. It's pretty tight, but if you go too tight, you can mess up the threading. So make it tight, but not too tight. So right now, this is the pressure. When we are working with this in class, we use a different pressure unit. Notice there's a lot of different possible pressure units. I'm going to change my unit to, a lot of people might be more comfortable seeing pressure in millimeters of mercury. If you think of storms, so standard pressure for millimeters of mercury is 760. So you notice in the lab today, it's just barely under. When we're using stuff with gas laws in class, you're going to see us measuring things in ATMs. But just a second, I'm going to click on PSIs because I know a lot of students who bike or work on cars are used to seeing PSI. So 14.7 is your standard pressure just walking around the room. So we're just a little under. And then I'm going to put it on ATMs. So standard ATM should be 1. So again, we're just a smidgen under, we're really, really close. I haven't done anything to this. I haven't moved it, I haven't changed it. So we're at this ATM. In the procedure, it says that this internal volume that you're gonna add to the measurement is 0.7. So this is actually 10.7 is what it is. What I'm gonna do is I'm going to increase the volume. So I'm going to make this get larger and larger and larger. And we're gonna take a pressure reading on how the volume changes. So this is 10. So I'm gonna increase right here. So now I'm at 12. You're gonna have to make a choice on that pressure reading. Now I'm gonna go on up to 14. And I'm increasing the volume. And hold it really steady. Okay, I'm gonna keep going. I'm gonna go up to 16. And then I'm gonna go to 18. And then I'm going to 20. This is harder and harder to hold, just like with anything. You're syringing out something and trying to hold it steady.
Let's review the reason behind what's going on in this simulation where you can actually see the gas particles. So this is our container full of gas. Notice at this point we have how many wall collisions? See, 90. 95, 93, quite a few. Let's see how many collisions we have when our container is almost twice the length. $60, $56, $49. This is help understand why when the volume increases, there is less pressure.
Now I'm gonna put it back to 10, which was where we started. And we're gonna record what happens if we make the volume smaller. So notice, in this case, when we were making the volume bigger, you should have seen a trend with what was happening with the pressure. If you look back at your values, you should see exactly that there's some kind of a trend. As you get the volume bigger, something happens to the pressure. Now we're gonna make the volume smaller, and let's see what happens to the pressure. So I'm gonna go from 10 to 8. And again, this is really 8.7. Okay. I'm gonna hold it steady. There. Now we're going to 6. And just like anytime you're trying to hold a lid or something on a container, maybe you've shaken it with carbon dioxide or something, it's harder and harder to hold it. Okay. And then I'm going down to 4. I don't think I can do any more than 4. It's really pushing against me here. I can't hold it steady enough. All right. I would just make a guess here. So you should have seen a different trend it's actually the same trend. As you make the volume smaller, what happens to the pressure? What you're gonna do is you're gonna take these points and you're gonna put them in an Excel graph and you're gonna plot them so that you can see what happens to the volume and the pressure.
So let's see what happens when we decrease the size of this container. If you remember, originally it had in the range of around 90, so that's 83, 94, 82, so 80 to 90. Let's make this container very small, or as small as it'll let us get it. So 80 to 90 is what it was. 124 collisions. 105 collisions. 135 collisions. So you can see that you have a lot more collisions in the small container and a lot less collisions in the very large container. This is the only gas relationship where we are going to see an indirect behavior. What that means is that when you increase one of the variables, you have to decrease the other to maintain consistency. So for example, if they began as 1 and 1, but then you increase this to 10, the only way that you would still maintain the constant of 1, because 1 times 1 is 1, is by decreasing your volume to 1/10. That's what an indirect relationship is all about. The rest of the gas relationships are direct relationships where they change in the same way.